You don't like roller coasters?
They scare me. Okay, here we go. Hey, 10.4, Student Journal. This is page 324 of your Student Journal. That would have been awesome. That's like a good sign. You turn right to the page. Yeah. All right.
Oh, dang nabbit.
In your own words, write the meaning of each vocab term. This will be a good thing for you to do after the lesson, just to make sure that you recall what we've talked about today. It's a good way for you to summarize it. Okay, core concepts. Inverse relation. Inverse relation is when a relation contains AB. The inverse of it is BA. In other words, you're just switching your x and y values. I don't know why they didn't use x and y here, but I would think of it as the coordinate xy. The inverse relation is yx. You just switch those values. And that applies whether you're in an equation, you're in a coordinate, you're on a graph, no matter what. If you're doing the inverse, you are just switching your x and y values. Okay? So that right there is a key thing. Is that the same one I got a minute ago? Here, you can leave it right there. Thank you. Okay. I might get like 10. I could share one with everyone. Yeah. Okay? Hey, so inverse, just switch x and y. If you haven't wrote that down, that is like one of the primary biggest things you can learn today. I know it sounds really simple, but that's the truth. You know the big idea? Help Gunner. What's the biggest thing that he can learn right now? No one wants to help you. Quinn? Yeah, inverse. Switch x and y. Okay? All right. So finding inverse functions algebraically. Set y equal to f of x. In other words, if you see f of x, just write y instead. Okay? Switch x and y, and then solve for y. Those are your steps. You'll see it here in a minute. In fact, you'll see it right now. Let's do one of these. So turn to the next page. Let's go to number 3. It says, in exercises 3 through 5, solve y equals f of x for x. Now right there, if you're not mathematically oriented, or even if you are, you may have to read that like 6 times just to understand what they mean. You're like, what? Solve y equals f of x. What are they talking about? All that means is y equals f of x. So in other words of saying f of x, scribble it out and put y. That's what this part means. So if you're like, I didn't understand that until McCoy just scribbled that out and put y, then you should make a note to yourself. Scribble out f of x and put y. That's what that means. Substitute y for f of x. Okay? And then solve that for x. What's it mean to solve for x? It means get x. No. When it says solve for something, it means get that thing alone on one side. So if I'm solving for x, it means move everything away from x. Okay? So, subtract 3 on both sides. We get y minus 3 equals x. There you go. You have now solved for x. And then they do kind of backwards things. They say, then find the input when the output is 3. Well, input refers to which variable? X. Output refers to y. So it's kind of convenient that we have it solved for x, because now we can put 3 in for y. That becomes 3. And we can solve for x. So when y is 3, x is 0. Okay. Which, by the way, would be a coordinate, but you can leave it in that format. All right? Questions there? It's not too bad once you know what they're asking you to do. Okay. Once again, this is one lesson in a chapter of lessons. So if any of that was confusing a minute ago, you should clarify what it means in your own words right above it. That way when you study for your test or quiz, you have it. I want you to try number 4 and 5, please.
I'm so random. I think this.
Okay, if I solve for x, after I make f of x be y, I add 2 and then divide by 3, so it's y plus 2 over 3 equals x. And then my input, find my input when my output is 3, so I get 3 plus 2 over 3, which is 5 over 3 equals x. Questions there? Somebody got it? All right. This one here, y, 4x squared, divide by 4, and then take the root. So y over 4 equals x squared. Take the square root, be plus minus, the square root of y over the square root of 4 equals x. And remember, the root of 4 is just 2. All right? Yeah? No, because you can simplify the 4 part. Yeah. And then from there, when our output is 3, that's plus root 3 over 2 equals x. And then your minus would be negative root 3 over 2 equals x. Okay, so 2 different answers there. If you wanted to write it as positive negative root, you could have said plus minus root 3 over 2 equals x. You could have wrote it like this and just not even put that part if you want to save some time. Okay? Aaron, you got it. All right. Questions? Okay, let's go back up to the easy problems. It says, find the inverse of the relation. A relation is just when you have a coordinate. So any coordinate is called a relation. This is a relation, that's a relation. Find the inverse of the relation. Look back to what inverse means. Okay? I want you to try number 1. You guys, this seriously is just switching your values. That goes there, that goes there. You just switch your x and y's. Oh my. Don't even know who that is. Take your word for it. Okay? Switch x and y. Switch your input output. 4, negative 3. 2, negative 1. 2, 0. 5, 1. 3, 3. That one was easy. Okay. Oh, did I say number 2? That's number 2. Okay. Why do we use that? Well, when we're graphing these, if we know how to graph one of them, then it's just as easy as switching your x and y values to graph the other one. So if I have my grid there and I have to graph f of x equals 3x minus 1, remember y equals mx plus b? Okay, so b is our y-intercept. Unbelievable, never had such a hard time. Okay, it's negative 1. Our slope is 3. We have our graph. So here's the original function. And when we're labeling it, let's label it as f. Okay? Then graph its inverse. Well, it actually says find the inverse first. Remember, if you're finding the inverse of this, we change this to y, like we've done. You know, y equals 3x minus 1. You add 1 over. Y plus 1 equals 3x. And then you divide by 3. Okay? You end up with y plus 1 over 3 equals x. Okay, now if I'm graphing that, usually what you're doing, if you're finding the inverse of the function, once you're done solving for x, you swap your values here so you can graph it. Okay? So this value becomes x. This value becomes y. That is the inverse function. The way we would write that is rather than saying y equals, because you already have a y equals, or f of x equals, you would write it as x plus 1 over 3 equals, no longer y, we'll call it g of x. Okay, so we just did a lot of stuff there. So let's figure out where people are. How many of you understood how I graphed it? How many people understood me solving for x? How many of you got lost right here? Okay. So once you have it set, x equals y plus 1 over 3. If I said to graph that using patterns like y equals mx plus b, most of you would have a rougher time doing that. If I said use a table, you'd be able to do that. You couldn't put it in your calculator with it in terms of x. So the way we graph them is we think of it as the inverse. We just switch our x and y values. Okay? So when you're dealing with an inverse function, remember the inverse function will be when you swap these two, just like up here where we swapped x and y. Okay? So we can switch x and y here. So all we're going to do is call that now y and call that now x. Okay? And so since we're going to have it in function notation, we can't call y, we'd have to call it like f of x, but we can't use f of x because that's already been used. We call it g of x. G of x is equal to x plus 1 over 3. And some of you would still have a hard time graphing that in that format. That is the same as g over 3, or excuse me, x over 3, and 1 over 3, which is still not fun to graph because you have fractions there. That would be 1/3 x plus 1/3. Like your y-intercept would be 1/3. The easiest way to graph these, once you, like they've asked you to find the inverse function. So if you can get to there, you're good. The easiest way to graph them is just to look at the graph of the first function. Okay? This point right here, the coordinate is 0, -1. Okay? What's the inverse of 0, -1? Almost. -1, 0. That's that point right there. Okay? What's this coordinate? 1, 2. What's the inverse of it? 2, 1. Okay? So I'm going to write these in pen for the... So the inverse 2, 1. This inverse, you switch -1, 0. Okay. What's this point? -1, -4. So the inverse, -4, -1. Notice you have 3 points now that you could draw a line through. That is the inverse function. Notice it looks like, just like we talked about here, 1/3 x plus 1/3, it looks like it crosses at 1/3 on the y-axis. Okay, and if we rise 1, that would bring you to here, and you'd run 1, 2, 3, that would bring you there. The slope. Yeah?
So if that's the inverse, would we even have to solve the equation?
You've still been asked to write the inverse function.
Okay.
Yep. But you can graph just like we did there. It's as easy as switching x and y. Okay? All right. Why don't you try number 7, please? Graph it, find its inverse. I'm going to try to clean this up a bit so we can keep track of where we're at. What's that? Yeah, just go ahead and put your axes right here. Oops. You know what, I'm going to find, I have a different grid here. All right, I got a clean copy there. Remember, your slope is negative, so you're going down from left to right. There's your graph of f. Okay, so I've got the graph of f. Remember, I could just reflect all these coordinates. Actually missed a point down there. Okay, we get it? Inverse function, if we solve this for x, there's my inverse function, as long as I switch my variables around. So I'd have to say x minus 2 over negative 3 equals g of x. Got one little piece left, and in order to do that, I'm not going to have you find the inverse function here. I just want you to graph the two functions on the same grid. If you found the inverse function, fantastic. But I want you to graph those two functions on the same grid so we can compare all three functions that you graphed. While you're doing that, I'm going to redraw this one over here. Yeah. You can. Yeah.
You marker?
John, focus on your Mathica. Okay, how many have at least the line drawn? Okay, I want you to watch what I'm doing. Stop what you're doing and watch. Stop what you're doing and watch. Just watch. Anyone know where this one will go? Some of you stopped watching already. It's all right. Okay, explain how I graphed that. Tell your neighbor, how did I graph that? Hey, anyone have a good description on how I graphed that? Kai, what do you think? Okay, it could have been. That's not how I graphed this one. Like, physically, what was I doing as I was drawing all these lines? Will you knock it off? Just act like a high school just like a whole period, a high schooler. Like a mature high school student.
I don't know if he's got that in him.
He has it. I know he can do it. Sarah? Yes, this line right here, this dashed line is called y equals x. Very true. Okay, what am I doing with that right angle? There's a mathematical term for what I did from here to here and here to here. Over that line, y equals x. Good job with the y equals x. Yeah. Yeah. I reflected each point over the line y equals x. Now notice this point is on that line, so it didn't move. Another property of an inverse is the points are reflected over the line y equals x. For those of you who are like, that whole y equals x thing is confusing me, it's just the diagonal line. Think of it as like your diagonal axis. Okay? It's a diagonal line. Y equals x. It's where you'd have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Y equals the same thing as x. 6, 6. Okay, you use the same points. So when you're doing an inverse, all graphs, notice this graph right here. If I was to draw in y equals x, you did that on yours, it's a reflection. In your first one, if you draw in that line y equals x, it is a reflection over that line. All your graphs that are graphs of inverses are reflections over the line y equals x. That is key. You're going to start an assignment here in a minute, and they're going to say, hey, what's the inverse of this? And they're going to give you a bunch of graphs that you can compare. Very easy to tell which one's an inverse when you know that rule right there. You don't have to compare points. You can, like we did here. It's just a reflection. Okay. Questions?